Dear students, I am Rajathgiri, Assistant Professor, Government First Aid College, Tumkur. Today, in the first session, I am going to discuss about the number theory concepts. This in the final year BSc topic. Okay. In the first session, I would like to give introduction about this theory of numbers. Okay. Now you are all familiar how much the numbers are important in day-to-day life. But in the once upon a time, what our the peoples has been done. Okay, a number is a mathematical object used to count and for measuring purpose and for labeling purpose. It has required many applications. This number system. Okay. Now earlier the humans counted every objects or for measurement or something else it is required. The number is essential. Our earlier humans carving on the cave, on wall and wood and somewhere for reference they are going to carving ಅಂದರೆ ಹಿಂಗೆ ಕೆತ್ತನೆ ಮಾಡುವುದು ಒಂದು ರೆಫರೆನ್ಸ್ಗೋಸ್ಕರ ಅವ್ರು ಏನು ಮಾಡ್ತಾಯಿದ್ರು ಒಂದು ಲೈನ್ ಹೇಳ್ಕೊಳೋದು ಇನ್ನೊಂದು ಅಡ್ಡ ಲೈನ್ ಎಳೆಯೋದು ಈ ರೀತಿ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಫಾರ್ ರೆಫರೆನ್ಸ್ ಆಗಿನ ಕಾಲದಲ್ಲಿ ಆ ರೀತಿ ಮಾಡ್ತಾಯಿದ್ರು ಬಟ್ ಆಫ್ಟರ್ ದ ಸಿವಿಲೈಜೇಷನ್ ಡೆವಲಪ್ಸ್ they come up with a different way of writing the numbers. Okay. Rome's and in Greeks, Babylonians and other peoples of the different countries, they have suggested the way of writing the numbers. Even today we are using the Roman for the heading purpose. Usually ನಾವೇನು ಮಾಡ್ತೀವಿ, that is capital I, that is 1, for 5 capital 5, for 10 that is capital X ಅನ್ನು ಡಿನೋಟ್ ಮಾಡೋದು. those are Roman letters. That Roman letter is not convenient when the numbers are big. Here in the slide I showed one example. Observe here, the 1975 is written like that. Okay, MCMLXXV. You know that what are that? M represents, X represent, that is 10. Okay, C represent. Okay, that is 1975 is written like that. It's difficult to write. Also, it's a very lengthening process when the numbers are big. So therefore, Roman the system is not suitable. Okay, after that civilization, our Indian great mathematicians in the 5th and 6th centuries, Aryabhatta and Brahmagupta, and even Arabs also they have contributed the beautiful the number system from 0 to 9. So from 0 to 9 there are 10 digits, that is you are familiar, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Even today we are using this system only. Okay, after later on this the number system, that is 0 to 9, what we are using, this is called Indo-Arabic system ಅಂತಲೂ ಹೇಳ್ತೀವಿ ಅದನ್ನು. Okay, after that when the days pass on, the format Gauss, G.H. Hardy and our own the scholar, that is Srinivas Ramanujan, and many more mathematicians contributed to the development of number theory. Okay, now before taking the important concept of this number theory, just I would like to recap what you studied in our elementary school levels. You know that that set of all natural numbers is denoted by n, that is 1, 2, 3, 4 like this. Also we call it as the God given numbers ಅಂತಲೂ ಹೇಳ್ತಾ ಇರ್ತೀವಿ ಇದನ್ನು. And then integers, that is I or Z, that is including 0 and the negative signs of the natural numbers, that is integer. and rational numbers is of the form p by q, where q should not be is equal to 0. The denominator should not be is equal to 0. Those numbers are called rational numbers. And real number is a union of rational and irrational. Rational and irrational. Actually, in so far we have two the number systems. One is real number system, another one is complex number system. That's real is the union of rational and irrational, whereas complex number is of the form a plus ib. Here the parts, a is the real part and b is the imaginary part. I is an imaginary number. The value of I is root of minus 1. Root of minus 1. Now let us take the very integral part of this session. That is divisibility. Divisibility. As the word itself says, that divisibility means division. Division. Okay. Let us see the proper definition of this. Definition of divisibility is a non-zero integer a. A non-zero integer a. Non-zero means the a should not be is equal to 0. A non-zero integer a is set to divide an integer b. A non-zero integer a is set to divide an integer b if there exists a third integer k such that b is equal to ak. Such that b is equal to ak. ಅಂದರೆ ಎ ನಾನ್ ಝೀರೋ ಇಂಟೀಜರ್ ಎ ಅನ್ನೋದು ಶುಡ್ ನಾಟ್ ಬಿ ಇಸ್ ಈಕ್ವಲ್ ಟು 0. ಅದು ಈ ಸೆಟ್ ಟು ಡಿವೈಡ್ ಅನ್ ಇಂಟೀಜರ್ ಬಿ. ಓಕೆ, ಎ ಅನ್ನೋದು ಬಿ ಅನ್ನು ಡಿವೈಡ್ ಮಾಡಬೇಕು. ಡಿವೈಡ್ ಮಾಡಿದಾಗ ಯು ನೋ ದಟ್ ದೇರ್ ಎಕ್ಸಿಸ್ಟ್ ಅನದರ್ ಇಂಟೀಜರ್, ಐ ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಕೆ, ಸಚ್ ದಟ್ ಐ ಈಸ್ ಆಫ್ ದ ಫಾರ್ಮ್ ಬಿ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎ ಕೆ ಆಗಿರುತ್ತೆ. ದೇರ್ ಇಸ್ ಒನ್ ಎಕ್ಸಾಂಪಲ್ ದಟ್ ಈಸ್ ಇನ್ ಸಿಂಬಲ್ is written as if a divides b is equal to k implies b is equal to ak. That see that symbol in the number theory, that is a divides b, read it as a divides b is equal to k implies b is equal to ak. For example, I have taken one example. 3 divides 15, correct? Is it divides? Yes, 3 divides 15. If you divide 3 from 15 from 3, there exists an integer 5, because that is 5 times of 3 is 15. Therefore, because 15 is equal to 5 into 3. I have taken another example. That same 3 does not divides 11. 3 does not divides 11 because 11 is equal to 3 into k. As from the definition of divisibility, I have said b is equal to ak. Like that, 3 does not divide 11 because it won't satisfy this relation. 11 is equal to 3k. Here k does not exist. Here k does not exist. No one integer satisfies this relation. 11 is equal to 3k. ಆ ಕೆ ಅಲ್ಲಿ ನೀವು ಯಾವುದೇ ಇಂಟೀಜರನ್ನು ಹಾಕಿದ್ರು 3 ಇಂಟು ಕೆ ಇದೆಯಲ್ವಾ, ಆ ಕೆಗೆ ನೀವು ಯಾವ ಇಂಟೀಜರನ್ನು ಹಾಕಿದ್ರೂ 11 ಬರಲ್ಲ ಅಲ್ಲಿ. ದೇರ್ ಫಾರ್ 11 is equal to 3k ಆಗಬೇಕು ಅಂದರೆ there should be an integer k. That integer should divide that number. ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, 3 does not divides 11. So therefore we can say that there is no integer satisfies this relation. ಇಲ್ಲಿ ಇನ್ನೊಂದು ನೀವು ಜ್ಞಾಪಕ ಇಟ್ಕೋಬೇಕು, that number theory is always deals with the integer set only. ನಾವಿಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡೋದು ಓನ್ಲಿ ಇಂಟೀಜರ್ಸ್. ಓಕೆ, ಸೊ ನಾವು 3 ಡಸ್ ನಾಟ್ ಡಿವೈಡ್ಸ್ 11. ಯಾಕೆಂದರೆ ಡಿವೈಡ್ ಮಾಡಿದ ತಕ್ಷಣ ಇಂಟೀಜರ್ ಬರಬೇಕು. ಸೊ ಇಲ್ಲಿ ಇಂಟೀಜರ್ ಬರಲ್ಲ ನಿಮಗೆ. ದೇರ್ ಫೋರ್ ಆಲ್ಸೋ 3 ಡಸ್ ನಾಟ್ ಡಿವೈಡ್ಸ್ 13. ಆಲ್ಸೋ 3 ಡಸ್ ನಾಟ್ ಡಿವೈಡ್ಸ್ 14. 3 ಡಿವೈಡ್ಸ್ 12. 3 ಡಿವೈಡ್ಸ್ 12 ಆಗುತ್ತೆ. 3 divides 6 ಆಗುತ್ತೆ. 3 does not divide 7. 3 does not divides 8. Like this. Okay. So now let us move on to next slide. Now as in the showed in the previous slide, the symbol that divides symbol, this one, the symbol that slash stands for divides. Okay, in the number theory, that symbol stands for what? Divides. A divides b. ಅದೇನು ಬರ್ತೀವಿ ನಾವು? A divides b ಅನ್ನು ಯಾವ ರೀತಿ ಓದಬೇಕು? Read it as A divides b. A divides b. That A divides b as a we can see that in different angles. ಅದನ್ನು ಬೇರೆ ಆ್ಯಂಗಲಲ್ಲೂ ನಾವು ಯೋಚನೆ ಮಾಡಬಹುದು. ಯಾವ ರೀತಿ ಅಂದರೆ A divides b ಅನ್ನು A divides b stands for ಏನಂತ ಅರ್ಥ ನಾವು ತಿಳ್ಕೊಬೇಕು ಅಂದರೆ A divides b is nothing but A is a divisor of b ಅಂತಲೂ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. A is a divisor of b. A divides b ಅಂತ ಬರೆದ ತಕ್ಷಣ A is a divisor of b. ಅಥವಾ a is a factor of b, or b is divisible by a, or b is a multiple of a. These are different the meanings of this a divides b. Okay, now some elementary properties of this divisibility. If a is any non-zero integer, then a divides a and a divides 0. a ಅನ್ನೋದು non-zero integer, a should not be is equal to 0 ಆದಾಗ then a divides a and a divides 0 ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ if a divides b ಆದರೆ then a is also divides minus b, ನೆಗೆಟಿವ್ ಇಂಟಿಜರ್ ಅನ್ನು ಡಿವೈಡ್ ಮಾಡುತ್ತೆ. minus a is also divides b and minus a divides minus b. And third one is if a is non-zero integer, then 1 divides a and minus 1 is also divides a. And the fourth one, the only divisors of 1 are 1 and minus 1. Again, the only divisors of minus 1 are 1 and minus 1. These are all elementary properties. Without the proof, we can accept this one. Okay, just you can take counter examples. Okay, now this is the elementary properties. Another one, that the relation, the divisibility relation is not an equivalence relation ಅಂತ ಹೇಳಿದ್ದೀವಿ. ಅಂದರೆ divisibility ಅನ್ನೋದು ಒಂದು ರಿಲೇಷನ್. ಅದು divisibility stands for is a relation, is not an equivalence relation. ಯಾಕೆ ಈಕ್ವಲೆನ್ಸ್ ರಿಲೇಷನ್ ಆಗಿಲ್ಲ? ಬಿಕಾಸ್ ಡಿವಿಸಿಬಿಲಿಟಿ ಈಸ್ ರಿಫ್ಲೆಕ್ಸಿವ್ ಅಂತೆ, ಬಟ್ ನಾಟ್ ಸಿಮಿಟ್ರಿ. ಈಸ್ ರಿಫ್ಲೆಕ್ಸಿವ್, ಟ್ರಾನ್ಸಿಟಿವ್ ಆಗುತ್ತೆ, ರಿಫ್ಲೆಕ್ಸಿವ್ ಆಗುತ್ತೆ, ಟ್ರಾನ್ಸಿಟಿವ್ ಆಗುತ್ತೆ, ಬಟ್ ನಾಟ್ ಸಿಮಿಟ್ರಿ. ಇಫ್ ಆಲ್ ದ 3 ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈಡ್, ಯು ನೋ ದ್ಯಾಟ್ ಈಕ್ವಲೆನ್ಸ್ ರಿಲೇಷನ್ ಆಗಬೇಕಂದ್ರೆ ಯಾವ್ಯಾವ ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಬೇಕು? ರಿಫ್ಲೆಕ್ಸಿವ್, ಸಿಮಿಟ್ರಿ ಆ್ಯಂಡ್ ಟ್ರಾನ್ಸಿಟಿವ್. If all the 3 conditions satisfied by a relation, then we can say that that relation is a equivalence relation. If any one of that reflexive, transitive and symmetry ಯಾವುದೇ ಒಂದು ಫೇಲ್ ಆಯಿತು ಅಂದರೆ that relation is not a equivalence relation. Here divisibility is a relation. Divisibility is a relation. Example ಇದೆ ನೋಡಿ ಅಲ್ಲಿ, 2 divides 2, that is divisibility relation is reflexive. Reflexive ಏನು ಹೇಳುತ್ತೆ? So x related to x. Example, 2 divides 2. Divides is a relation. So therefore 2 divides 2. It's true, no? 2 divides 2, 4 divides 4, 3 divides 3, 10 divides 10. It's true. Okay? Therefore that is called a reflexive relation. Next take. Another in 2 divides 4, but 4 does not divides 2. Correct? 2 divides 4 ಮಾಡುತ್ತೆ, but 4 does not divides 2. ಅಲ್ಲಿಗೆ ಏನಾಯಿತು? ಎಕ್ಸ್ ರಿಲೇಟೆಡ್ ಟು ವೈ ರಿಲೇಟೆಡ್ ಟು ಎಕ್ಸ್ ಆಗಿದ್ದಿದ್ರೆ ದೆನ್ ವಿ ಕ್ಯಾನ್ ಸೇ ದಟ್ ಇಟ್ ಇಸ್ ಎ ಸಿಮಿಟ್ರಿ. ಬಟ್ ಹಿಯರ್ ಏನಾಯಿತು? ಎಕ್ಸ್ ಈಸ್ ರಿಲೇಟೆಡ್ ಟು ವೈ ಇದೆ, 2 divides 4, ಬಟ್ 4 ಡಸ್ ನಾಟ್ ಡಿವೈಡ್ಸ್ 2. Therefore the divisibility relation is not symmetry. 2 divides 4, but 4 does not divides 2. Therefore divisibility relation is not a symmetry. Symmetry ಆಗಲ್ಲ. ಬಟ್ the divisibility relation is transitive ಆಗುತ್ತೆ. ಟ್ರಾನ್ಸಿಟಿವ್ ಏನು ಹೇಳುತ್ತೆ? ಎಕ್ಸ್ ಈಸ್ ರಿಲೇಟೆಡ್ ಟು ವೈ ಆಗಬೇಕು, ವೈ ಈಸ್ ರಿಲೇಟೆಡ್ ಟು ಝೆಡ್, ಥರ್ಡ್ ಇಂಟೀಜರ್ ಇನ್ನೊಂದು, ಎಕ್ಸ್ ಈಸ್ ರಿಲೇಟೆಡ್ ಟು ವೈ ಆ್ಯಂಡ್ ವೈ ಈಸ್ ರಿಲೇಟೆಡ್ ಟು ಝೆಡ್, ದೆನ್ ಎಕ್ಸ್ ಈಸ್ ರಿಲೇಟೆಡ್ ಟು ಝೆಡ್, then it is called transitive relation. I have taken one example, transitive relation, because 2 divides 4 and 4 divides 8. It is true, no? 2 divides 4, 4 divides 8. It is true. Then 2 divides 8. This is also a true. Therefore, transitive relation satisfied, but symmetry is not satisfied. Therefore, overall we can say that divisibility relation is not an equivalence relation. Another important the concept of this session is division algorithm. Okay, algorithm is a systematic process of writing. Okay, algorithm, you are familiar with the word algorithm. Is a systematic way of writing. Okay, step by step, that is algorithm. Okay, division algorithm, division ಅನ್ನು ಮಾಡಿದಾಗ, so we can write it as an algorithm, because using that algorithm we can solve some other problems also. Okay, it requires that division algorithm is required for the next sessions also. Now if a is greater than 0 and b are arbitrary, here both a and b are arbitrary. Here both a and b are arbitrary integers. ಎರಡನ್ನೂ arbitrary ಆಗಿ ತಗೋಬೇಕು, ಯಾವ್ದು ಬೇಕಾದ್ರೂ ತಗೋಬೋದು, arbitrary integers. ಬಟ್ ಕಂಡೀಷನ್ ಈಸ್ a should be greater than 0 ತಗೋಬೇಕು. ಓಕೆ, ದೇರ್ ಎಕ್ಸಿಸ್ಟ್ ಟೂ ಇಂಟೀಜರ್ಸ್, q and r ಯುನೀಕ್ಲಿ, such that ಯಾವ ರೀತಿ ಇರುತ್ತಂದರೆ ದಿಸ್ b is equal to aq plus r, where r should be greater than or equal to 0 and less than a. ಏನಿಲ್ಲ, ಇಲ್ಲಿ ಡಿವಿಷನ್ ಆಲ್ಗರಿದಮ್ ಅಂತ ಹೇಳಿದ್ರೆ ನೀವು ಒಂದು ನಂಬರಿಂದ ಇನ್ನೊಂದು ನಂಬರನ್ನು ಡಿವೈಡ್ ಮಾಡಿದಾಗ, ಯು ಆರ್ ಆಲ್ ಫೆಮಿಲಿಯರ್, ಯು ಸ್ಟಡಿಡ್ ಇನ್ ಯುವರ್ ಲೋಯರ್ ಕ್ಲಾಸಸ್, ಈವನ್ in almost all the classes we are using the division concept. Once you divide one number from the another number, what exists? Remainder exists, quotient exists. Correct? That is the written here, where a is called a divisor, b is called a dividend, q is called quotient, and r is a remainder. The important thing is here remainder should be greater than or equal to 0. The remainder may be a 0 or greater than 0, but the condition is strictly less than a. What is a? A is a divisor. This is called division algorithm. And division algorithm, some properties. Okay, it's also not we can take up in the next session the proof of this one, division algorithm property. Just I would like to inform these properties. If a and b are non-zero integers such that a divides b and b divides a and b are non-zero integers ಆದರೆ ಈ ಥರನೂ ಆಗುತ್ತೆ, a divides b and b divides a ಆಗಿದ್ದರೆ then a is equal to plus or minus b. Okay, if a divides b and b divides c, then a divides c. That's like transitive law, as mentioned in the previous slide regarding equivalence relation. Okay, that comes now, a divides b and b divides c, then a divides c. That is called transitive law. Another one is third one condition, a divides b and a divides c, then a divides b plus c. It's an addition. A divides b minus c, subtraction, and a divides b c. It's a multiplication of this. And the fourth one, if a divides b and x is any integer, then a is also divides bx. If a divides b and c divides d ಆದರೆ, then numerator, that's ac, the multiplication of ac divides bd multiplication, that is ac is also divides bd. If a divides b and a divides c, then x is any integer ಆದರೆ, then a divides bx plus cy for all integral values of x and y. So these are the elementary properties of this division algorithm. Those proof let us take up in the next session 2. Okay, now I have referred these textbooks, David Burton, number theory, and textbook of BSc Mathematics by B.V. Manjunath and Dr. C. Nandish Kumar. Okay, thank you very much.